Okay, so this is the predicted paper made by First Class Maths, who wrote the most incredible past papers last year that had a really true likeness to the exams. We don't have any prior information this time, so this is a best guess based on all the information, and you can see more about how he's come up with this paper here. We've got questions that have come up loads. I'm going to film my own tutorial for this one, and hopefully you find it helpful. Let me know in the comments if you've got any questions. Okay, so question number 1. A is 2 cubed times 5 times 31. Write 6a as a product of its prime factors. So we can see that they've already written a as the product of its prime factors. We've already got it broken down as a prime factorisation. We now want 6a, and we know that that is 6 lots of a. So we're going to take a, which we know is 2 cubed times 5 times 31, and we're going to times it by 6. But we know that this part is not in its prime factorisation, because we wouldn't ever, when we're breaking down like this, we wouldn't ever leave it as 6 because it's not a prime number. We need to break it down to be two numbers that multiply to make 6, which is going to be 2 times 3, and they're both prime, so we circle them. So instead of writing times 6, we're going to write 2 cubed times 5 times 31 times 2 times 3, because then we're taking that 6 and we're writing it as 2 times 3. So we wouldn't leave it like that. Let's collect up now, because this 2 can go with this one. So it's going to be 2 to the power of 4 times 3 times 5 times 31. Okay, question B. We've got 2 squared times 5 times 7 times 31, and we need to find the highest common factor. Now we would do that by using a Venn diagram. So I'm going to do a circle for A, and I'm going to do a circle for B. A we've already got up here, this is our A, and B we've got here. Now if it has both numbers, we can put it in the middle. So if this one's got 2 squared and this one's got 2 to the power of 4, we can put 2 squared in the middle, because that's what's in both. However, on A, we've got another 2 and another 2 left over to go on the outside. This one has a 3, but this one doesn't, so we're going to put that on the outside there. They've both got a 5, so we can put that in the middle. And B has got 7, so that needs to go on the outside. And they've both got 31, so that can go in the middle. Now, the highest common factor is all of the numbers in the middle multiplied together, which is going to be 2 times 5 times 31. Now, I'm going to be a bit clever with this, because I know that 2 times 5 is 10. I'm going to do that bit at the end, because timesing by 10 is easier. So I'm going to take the 31, times it by 2, which is 62, and then times it by 10, which is 620, and that would be your highest common factor. Okay, question number 2. Find the value of 32 to the power of 0. And we know that anything to the power of 0 is going to be 1 for the purpose of GCSE. Now for part 2, we're going to simplify this expression. Now I find it helpful when we've got these to write it out as many times as you are raising the power. So if we are cubing this expression, we're doing 3xy cubed times 3xy cubed times 3xy cubed. And then we can think, what does 3 times 3 times 3 make? And that would be 27. X times x times x, that would be x cubed. And then y cubed times y cubed times y cubed. We know when we times, we add the powers, so that's going to be y to the power of 9. You don't have to do that. You can think about each term in turn and cube each part, but I just find it easier to write it out and be clear about your working. Okay, question number 3. 20 students were asked how many siblings they had. The table shows some of the information. None of the students had more than 3 siblings, and the number of students with 1 sibling to the number of students with 3 siblings is in the ratio 1 to 2. So we know that this value here and this value here are in the ratio 1 to 2. Work out the mean number of siblings for the 20 students asked. So we know that this has to add up to 20 because they asked 20 students. We've got 8 in that column so far, which means there are 12 left to be shared between these two values. And we know that that needs to be shared in the ratio 1 to 2. Now I find with ratio, it can be helpful to do these little lines where we take the 12. If we're sharing it in the ratio 1 to 2, that means we've got 1 part on this side and 2 parts on this side. So altogether we need to take our 12 and divide it into 3 equal sections because there are 3 little lines there all together to share it over, which is 4.
If we put 4 on each line, we can see that this side is just 4, and on this side we have 8, which makes 12 and is shared in the ratio 1 to 2. So I'm going to go ahead and say that the number of students with one sibling is 4, and the number of students with 3 siblings is 8, so that goes there. That now adds up to 20. We've now got to work out the mean number of siblings, and to do that we times across. So there was one student, with no siblings, and altogether that would add up to 0. There are 4 students with one sibling, and altogether that would add up to 4. Let me make some room there. So that's 0, that's 4. There were 7 students with 2 siblings, and altogether that would be 14 siblings, and there were 8 students with 3 siblings, and altogether that would make 24. So in total, if I do 4, add 14, add 24, I guess we're adding 0 as well, we can put that there if you like, that's going to be 38, 42, and we need to divide it by how many students they asked, which is 20. Now, with your non-calculator paper, if you get a question that you don't particularly like in terms of dividing, we can write it as a fraction and simplify the fraction. So I'm just going to make this 21 divided by 10, and then it's a lot easier for me to do. I've just used equivalent fractions to make it a sum that I preferred. 21 divided by 10 is 2.1. Okay, question 4a. Complete the table of values for y equals x squared minus 2x add 1. So you might find this helpful without a calculator to break it down a little bit. So I'm going to put underneath, what would x squared be? What would minus 2x be? And then we'll just add on the 1. So I'm just breaking it down into 3 sections, and then we're going to get our total answer at the end and we can put it in. So when x is minus 4, don't forget we're putting it into this value and we're putting it into here as well. So minus 4 squared, a negative times a negative is a positive. So that's going to be 16. I've then got minus 2 times minus 4, which is positive 8. And then I've always got that plus 1 because we've got plus 1 there. That's not going to change no matter the value. So 16 add 8 add 1 is 25. So we know that that's 25. For the next one, if I do x squared minus 3 squared is positive 9, negative times a negative. I've then got minus 2 times minus 3, which is positive 6. And then we've got the plus 1, which is 16. Moving across to 0, I've got 0 squared, which is 0, minus 2 times 0, which is 0, and then we've got to add the 1. So that is just 1. 1 squared is 1, minus 2 times 1 is minus 2, and then we're adding 1, and that makes 0. We've now filled out all the values, so that would be the 2 marks up there, and we've just got to plot those values on the graph now. So we know that each of these is a coordinate, so minus 425, minus 316, and so on. So minus 425 is going to be here. I've then got minus 316, which is going to be here. Minus 29, minus 14, 0, 1, 1, 0, 2, 1, and 3, 4. There we go. And we would want to join that up with a nice smooth curve. It is a quadratic. I'll do my very best to join it up neatly, but do it in pencil in the exam. It's just easier, and then if you go wrong, you can always rub it out. There we go, perfect. So it would continue on up here, but we don't need to draw that bit. That's fine. So there we go, there's our quadratic, and that would be 4 marks. It then says, write down the coordinates of the turning point of the graph. So a turning point for a quadratic is either going to be a minimum, which is where it turns down there. If we'd drawn it the other way up, it would be a maximum, but either way, it's just the coordinate where that quadratic graph is turning. So here is going to be our turning point, and the coordinates of that graph of that point is 1, 0. Write down the equation of the line of symmetry. So where would it be symmetrical? Now we know a quadratic graph in this case is coming down and going back up, so it's symmetrical there. So we need to know what is the equation of this line here. And we know that that goes through the x-axis on 1. Every single coordinate on this line, like this coordinate, for example, is 1, 6. This coordinate is 1, 8. This coordinate is 1, 10. Every single coordinate on that green line would have an x coordinate of 1, and that is because it's the line x equals 1. Okay, question number 5. Here is a right-angled triangle. AB is 3 times 10 to the power of 4. Let's put that there. And AC is 8 times 10 to the power of 3. Write down the ratio A to B, A to C, give your answer in its simplest form. Okay, so we've got A to B we know is 3 times 10 to the power of 4. Let's put that on the left-hand side. And A to C we know is 8 times 10 to the power of 3. Now with ratios, just like fractions, if they've got something in common, we can divide by that. So I know I can divide this side by 10 cubed, and I can also divide this side by 10 cubed. So this would be 3 times 10 is all I'd be left with on this side, and on this side I'd just be left with 8, which is going to be 30 to 8. They're both in the 2 times table, so let's divide that by 2, and that would be 15 to 4. They're both not divisible by anything, so that's it, that's my answer, 15 to 4. Okay, question part B. Calculate the area of the triangle. So area is base times height divided by 2. So I'm going to take the base, which we know is 3 times 10 to the power of 4, times it by 8 times 10 to the power of 3, and then half it. So we've got 3 times 10 to the power of 4 times 8 times 10 to the power of 3, all divided by 2. Now, when we multiply with standard form, I can do 3 times 8, which is 24, times 10 to the power of, now when we multiply with the same base number, we just add the powers. So 10 to the power of 7, all divided by 2, which is 12 times 10 to the power of 7. Because this is multiplying, it's okay just to divide the first bit. Now, that's not in standard form. It says give your answer in standard form, so we need this part here to be a value between 1 and 10. And to do that, we're going to make it 1.2. But if you've made this part 10 times smaller, then you've got to make this part 10 times bigger, which is going to make it times by 10 to the power of 8. Question number 6. A machine can produce a new paperclip every 0.53 seconds. Find an estimate for the number of paperclips that 18 of this machines could produce in 1 minute. So I would say that one paperclip is made in 0.5 seconds. We are estimating here, and as soon as we're told to estimate, we know we can round to one significant figure. So 0.53, I'm just going to call that 0.5 seconds. So then I would say that 2 paperclips can be made in 1 second. And then I could say that in 60 seconds, because they're asking me about a minute, we would make 120 paperclips. But we've got 18 machines running. Now, instead of doing 18, I'm just going to say, what about 20? Because we're estimating, we're rounding to one significant figure. So I'm going to say I've got 120 paperclips, and I'm timesing that by 20 machines. So I'm going to times it by 2 and times it by 10, which is 2,400, roughly. Is your answer an underestimate or an overestimate? You must give a reason for your answer. So we rounded the time it actually took down. We said that it actually was quicker than it was, and we said there were more machines than there actually were. So our answer is going to be too big. It's saying the machines are quicker than they actually are, and it's saying we've got more machines running. So our answer is going to be an overestimate, as we rounded the time taken down and the number of machines up. And when you're rounding, it's important that you're thinking about which way you're rounding every element. If you were rounding a number that you were dividing by, it might have a different effect. So, and the number of machines up. Great. An athlete is going to run 2 laps of a 400-metre athletics track. The first lap is a warm-up, and they run at an average speed of X metres per second. The second lap they run at an average speed that is 5 times as fast as for their first lap. The total time taken to complete both laps is 320 seconds. Find the value of X, the average speed of the athlete during the first lap. So we're thinking about our speed, distance, time triangles here. In fact, let me put that up here. Speed, distance, time. And we've actually got 2 triangles to think about here. We've got the warm-up, and we've got the actual fast lap, let's call it that. So we know that the speed on the first one was X. That's the average speed during the first lap. we know that the second lap, the fast lap, was 5 times as fast, so the speed was 5x. Now we know that it was a 400 metre track, so we can put the distance as 400 in both cases. And we just want to know what the time is. So we're going to do 400 divided by x, that's the time for the first lap, and we're going to add 400 divided by 5x, that is the time for the second lap, the fast lap. Now to add those fractions together, I can't currently because they've got different denominators, so I'm going to need to change this fraction to also be out of 5x. And to do that, we're going to times it by 5. So 2000 over 5x, add 400 over 5x, is 2400 divided by 5x. In fact, we could have simplified that second one down, wouldn't have made a difference. So either way, if I simplify that now, dividing by 5 is the same as dividing by 10 and doubling it. So that is 480 over x. And it says that that takes 320 seconds. So we know that that equals 320. Now if 480 divided by x is 320, then 480 divided by 320 is x, just rearranging that around. And 480 divided by 320, now I said this earlier, if you get a division that you don't particularly like, just simplify it. So 480 divided by 320 is 48 over 32, which is 24 over 16, which is 12 over 8, 6 over 4, and 1.5 is our answer. Okay, question number 8. A bag contains only red, green and blue counters. The number of red counters to green counters to blue counters is in the ratio 3 to 4 to 5. 15 red counters and some blue counters are added to the bag. The ratio after this is shown below. Red counters to green counters to blue counters then becomes 7 to 6 to 8. Work out the total number of counters in the bag after the red and blue counters were added. Now, we know that there might not be 3, 4 and 5 counters. It's probably been simplified from bigger numbers, but I do know that whatever those numbers are, they're going to need to be in the 3 times table, the 4 times table and the 5 times table. So I'm going to call the before 3x to 4x to 5x. And afterwards, same thing. We then know it's going to be the 7 times table, the 6 times table and the 8 times table. So let's call it 7y to 6y to 8y. We don't know that the numbers they're timesing by are the same, so we're going to need to use different letters here. Now, what else do we know? We know that they've added 15 red counters. So the red is the first value, so we know that 3x add 15 needs to equal 7y. And we also know that no green counters were added at all. 15 red counters were added, some blue counters, but no green counters were added. So we also know that 5x is equal to... Oh no, green's the middle one. So we also know that 4x is equal to 6y. That's green, that one is green, that one is green, and we know that no green counters were added, so that's the same. Now using that information, if 4x is 6y, let's divide both sides by 4, and that tells us that x is 1.5y, which is helpful because at the minute I can't solve this equation because it has x's and y's in it, but using this information I can change the x to be 1.5y. So 3 lots of 1.5y, add 15 equals 7y. So 4.5y, add 15 equals 7y. Let's take 4.5y away from both sides. So 15 is 2.5y. So we need to divide by 2.5. And 15 divided by 2.5. Again, don't love that, having a decimal at the bottom. So I'm going to double it and make it 30 divided by 5, which we know is 6. So we now know that y is 6. So that means if y is 6, there were 42 red counters. There were 36 green counters, and there were 48 blue counters after they were put in. What did it ask us? The total number of counters in the bag after it was added, so we just need to add these 3 values together. And 42 add 36 add 48 is 126. Okay, question 9. Write 5 over 2xy squared minus 1 over x squared as a single fraction in its simplest form. So we can only add and subtract fractions if they have the same denominators. So we need to make these denominators the same. I've got 5 over 2xy squared minus 1 over x squared. Now how could I make it the same? It would be helpful if this fraction also was 2y squared, but then we're also going to need to put an x on this one. So we're going to need to use a common denominator of, let's do it down here, 2x squared y squared. That is the smallest we can make the denominator and get all of these elements into it. So I'm not just going to times them together because then I'd have x cubed and that's bigger than I need it. Now what have I done to this fraction to turn it into that? Well, I've timesed it by x on the bottom, so I'm also going to need to times it by x on the top. So there we go, 5x. On this fraction on the bottom, I've timesed by 2y squared. So I'm also going to need to times the top by 2y squared, and that is that. So we've got 5x minus 2y squared over 2x squared y squared. Can't simplify it down, nothing that I can divide everything by, so that would be my final answer. Question number 10. Here are some graphs. Here is a table showing some equations. Write down an equation from the table above that could be the equation of graph A. So all of these are linear equations in that we know they're of the form y equals mx plus c. Either they've got a positive gradient or a negative gradient, and they're going to be straight lines on a graph. So graph A is probably going to come from one of these, and we'll look in more detail in a minute. Now graph B would match up with one of these. Graph B is a reciprocal function. Now if it is positive, you get the reciprocal graph in these two quadrants. So that would be something like y equals 1 over x, or y equals 3 over x, or y equals 5 over x, whatever. It's positive. If it was negative, you end up with them in these quadrants. So we are going to be looking for a negative one for this graph in a minute. And then this one is a cubic. So a cubic is going to come from this section, one of these three graphs. Y equals x cubed is going to wiggle upwards and look like that. The plus 4 on this one would tell me that it would cross at 4. So we know that that couldn't be right. So let's have a look. We've just got to put a graph for A, a graph for B, a graph for C. Okay, so let's say that A, what do we know about it? We know that A has a positive gradient, and we know that it crosses the y-axis in the negative. So this first one has a positive gradient, but it would cross at plus 4. So that's no good. The next one has a positive gradient and crosses at minus 4. And the next one has a positive y-intercept of 4 and a negative gradient. So the second option, that is the one we're going to pick, y equals x minus 4. Now for graph B, we've got y equals 1 over x minus 1 over x. Right, so this is the only one that's negative. The other two would both be in the other quadrants. So it's got to be that second one, y equals minus 1 over x. And last but not least, we're looking for the cubic graph on the end. This one's negative, so that would wiggle downwards. This one's positive and going through the origin, so that's going to be y equals x cubed. Question number 11. Write 27 cubed times root 3 as a power of 3. So we're going to change 27 to be 3 cubed, but it's still being raised to the power of 3. And then I'm timesing that by 3 to the power of a half. We know that when we square root a number, it is the same as the power of a half. Now that is the same as 3 to the power of 9, because a power you times them together, times 3 to the power of a half. And when we times, we add the powers. So that's going to be 3 to the power of 9.5 or 3 to the power of 9.5, however you prefer to write it. Or I guess you could also say it's 3 to the power of 19 over 2. Any of those answers would be suitable for the 2 marks there. Okay, find the value of 1 over 27 to the power of minus 2 over 3. So we've got 3 things to worry about here. The negative makes the base number, this, its reciprocal. So the first thing I'm going to do is I'm going to write 27, that's the reciprocal of 1 over 27, and it's still to the power of 2/3. So I'm going to cube root, because we root by the bottom number, that wasn't very clear, was it? Cube root by the bottom number, and then do the power of the top number, so then we're going to square it afterwards. Okay, so the cube root of 27 is 3, still need to square it, so that is 9. 3 things to do because there were 3 parts to the indice, and the answer to that one was indeed 9. Okay, question number 12. A bag contains blue, red and green counters. A quarter of the counters are red. A counter is randomly drawn from the bag, its colour is noted, and then it is replaced back into the bag. A second counter is then randomly drawn from the bag. The probability that the first counter is red and the second counter is green is a sixth. Calculate the probability that both counters drawn are blue. So we've got red, blue and green. So let's do red, blue, green, red, blue, green, red, blue, green. You don't have to draw this out. It just helps you to visualise it. And when it's not too big, sometimes it can be helpful. So we know that a quarter of the counters are red, and we also know that that's being put back in. So all of these would be a quarter, because the probability of that second pick is not going to change if you're putting it back in the bag. But we know that the probability of red and then green is a sixth. So if I was to go up this pathway and then go down this pathway, we know that if I was to times those values together, let's call this x, a quarter times x equals a sixth, because we're told that that would be the probability of that happening. So to get that value x, we need to divide. And we need to do a sixth divided by a quarter to work out what x is. Now when we divide fractions, we keep the first fraction the same, change the divide to a times, and do the reciprocal, flip that second fraction, which is going to be 4 over 6, which is 2/3. So we now know that the probability of green is 2/3. The question asks us to work out the probability that both counters drawn are blue, so I actually need this probability. Now we know the probability adds up to 1, so I'm going to do a quarter, add 2/3, making the denominators the same because that's what we have to do when we're adding. So that's going to be 3, add 8, so 11/12, which means that the probability of blue must be 1 over 12. It would be the rest. If the probability of red and green is 11 out of 12, then the probability of blue must be 1 over 12. And we're putting that counter back in and we're picking it again. So the probability of blue and then blue again would be 1 over 12 times 1 over 12, because we've got to do this one and then times it by itself again. So that is going to be 1 over 144. Okay, question number 13. X equals 0.318 recurring. So I'm going to say let x equal 0.318181818 and so on. Now because there are 2 digits repeating, the 1 and the 8, I want to times this by 100. And that's going to move all of the values 2 place value columns over to the left. So I've got 31.818181818 and so on. And then I can subtract. I'm going to do the bottom row, take away the top row. So 99x equals 31.8, take away 0.3. Everything beyond that would cancel. 1 take 1, 8 take 8, and so on. It would all be gone. So I've got 31.5. So x would equal, dividing both sides by 99, 31.5 over 99. Can't leave a decimal point in the fraction though, so it's going to be 315 over 990, which is 7 over 22. Question number 14. The straight line L1 has the equation 2y equals 8 minus 5x, and the straight line L2 has the equation 10y minus 4x minus 15 equals 0. Hannah says L1 and L2 are perpendicular lines. Is Hannah correct? Well, I hope so. So let's see. We're going to take the first line and we need to know the gradient to know if they're parallel or perpendicular in either of those cases. And to do that, we need to make y the subject of the formula. So I know that 2y is 8 minus 5x, and y, we would need to divide both sides by 2, would be 4 minus 5 over 2x. Now I know for perpendicular lines we're looking for the negative reciprocal, so you don't really want to put 2.5 there if you can help it, because we want to kind of see, are the gradients, the number in front of the x's, are they going to be the negative reciprocal of each other? So the gradient of L1 is minus 5 over 2. Now let's look at L2, and I've got 10y minus 4x minus 15 equals 0. Adding the 4x to both sides and adding the 15 to both sides, I've got 10y equals 4x, add 15, and now we want to divide by 10. Now we could say, all divided by 10 in a minute, but we want, again, to look at each term in turn. I want this bit because I want the gradient, right? So I'm going to now divide by 10. So y equals 4 over 10x, add 15 over 10. And 4 over 10 simplifies to be 2/5. So now we can see that the gradient of L2 is positive 2 over 5. And since they multiply, that's probably the easiest way to check, that they multiply to equal -1, we know that they are perpendicular, but you could also say that one is the negative reciprocal of the other, so negative reciprocal. So yes, they are perpendicular. Yes, she is. Always answering the question if they've asked you. Yes, she is perpendicular. Yes, she is. They are perpendicular. There we go. Question number 15. And we need to do an enlargement, scale factor -1.5 with centre of enlargement -2, 3. So -2, 3 is here. And we need to enlarge our shape by -1.5. Now, a positive enlargement of 1.5 would make it 1.5 times bigger, going in this direction. So it would be maybe over here somewhere, looking like that. But because it's a negative enlargement, we're going through the centre of enlargement and back out the other side. So I'm looking at the gap from the centre of enlargement to the shape. So here, this point here is 2 diagonal squares away from the centre of enlargement. If I want to times that by 1.5, it's going to be 3. So I want to go in exactly the same gradient through the centre and out the other side. And that point would now be there. So this point is currently just 2 squares left. If I'm timesing that by -1.5, instead of going 2 squares left, from the centre of enlargement, we're going to go 3 squares right, and it's going to go there. This coordinate is currently 4 across and 2 down. So we're going to go 6 across and 3 up. So we're doing 1.5 times bigger, but in the opposite directions. And hopefully you can see that this is going to start to come together and where it's going to end up. That point up there is 4 across, 2 up. So let's go 6 across and 3 down. And it's going to go there. So connecting up, or let's use my straight line. Connecting up those values. And it should look the same in the same proportion. Should be a similar shape. And you could draw all your lines on if you wanted. So going through the centre, all of the corresponding coordinates should match up and go through the centre of enlargement. You don't need to, but it sometimes looks quite nice. So there we go. So it looks like that. Did we have to label it? Label your image B. There we go. So let's just call that B. Brilliant. Question number 16. The cumulative frequency graph shows information about the speeds of 80 vehicles on a road. Use the graph to find an estimate of the interquartile range of the speeds of the vehicles. So we know that when we've got a cumulative frequency graph, we need to look how many pieces of data there are. And in this case, that is 80. I can see that that's where my graph goes up to there. So the median would be at 40. I would read across, hit the graph, and go down. So if I was asked the median, I would say it is 23. But I haven't been asked the median in this case, but it's helpful to know how to find it. The interquartile range is the upper quartile, take away the lower quartile. Now the upper quartile is halfway between the median and the top of the graph, so that's going to be at 60. This is my upper quartile, and that is at 27.5. Now you might get slightly different answers to me, that's okay. And then my lower quartile would be at 20. So again, hitting the graph and going down, and I get 19 for that. So then the interquartile range is the upper quartile, take away the lower quartile, which would be 27.5, take away 19, which I got 8.5 for. The speed limit on the road is 30 miles an hour. Colin says more than 20% of the cars on the road were exceeding the speed limit. Show that Colin is incorrect. So let's get a different colour line and let's see how many cars were going faster than 30 miles an hour. So 30 miles an hour is here. If we go up to our graph, we hit that value and we go across, we can see that that lines up with 66. Now there are 66 cars here, but they all match up to speeds less than 30. So be really careful. Above that speed, we've actually got 14 cars. So we can see that there are 14 cars going over 30 miles per hour, and 20% of 80 equals 16. So Colin is wrong. There we go. Question number 17. The functions f and g are such that f of x is 8 over 3 add x for x greater than 0, and g of x is the square root of 2x add 1 for x greater than 0. Find f to the minus 1 of x. So this is the inverse function. We want the opposite function of this one, the one that would take the output and return the input. So to do that, I'm going to say y equals 8 over 3 add x. And the easiest way to find the inverse function is to change the subject of the formula. At the minute, y is the subject of the formula. Let's make x the subject of the formula. So to do that, I'm going to times both sides by x add 3, or 3 add x. So y x add 3 equals 8. So xy add 3y equals 8. I then want to make x the subject of the formula, so I'm going to write xy is 8 take away 3y, because I've taken that 3y away from both sides. And now I would divide by y to get the x on its own. So x equals 8 minus 3y, all divided by y. And now all we've got to do is switch the letters back round. We want this in terms of x. So f to the minus 1 of x is 8 minus 3x, all divided by x. For part B, it says find f of g of 2. So this is a composite function. We're putting 2 into g, and then we're getting the answer and putting that into f. So first we want to put 2 into g. So let's do g of 2, which is the square root of 2 lots of 2 add 1. That is the square root of 5, which is a surd, and we're then going to put that into f. So I now need to do f of root 5. Putting root 5 into f gives me 8 over 3 add root 5. Now we can't leave that as our answer. We're also told to leave it in this form, so we know that that's no good, but even if we weren't told that, we can't leave surds on the bottom of the fraction. The only way to get rid of a surd on the bottom of a fraction is to times it by itself, but if there are two terms like this, we need to multiply by something called the conjugate, which is just a fancy way of saying the same thing, but with the opposite sign. So we're timesing by 3 minus root 5. Now, multiplying that out, I've got to do 8 times the first thing, 8 times the second thing, so that's going to be 24 minus 8 root 5. All divided by, and now on the bottom I've got 4 terms here, so 3 times 3 is 9, but then I've got 3 times minus root 5, and then I've got root 5 times positive 3, so we'd get minus 3 root 5 plus 3 root 5, which is just going to cancel out, and then I've got root 5 times root 5, which is just minus 5, so that becomes 4, so I've got 24 minus 8 root 5, all divided by 4, which is 6 minus 2 root 5. And now it's in the format that they asked me for it in. So that matches that, and that would be our answer, 6 minus 2 root 5. Okay, question number 18. Now, looks terrifying, but don't be too scared of this, okay? What we need to think about is how can we make this simplified? This is going to be lots of marks here. What have we got? 5. And the first thing you're going to do is anywhere you see something that can be factorised, do it. So I'm going to start by making this 4 over 3, just because that's a bit easier as well. Divided by. Now, inside these square brackets, and just think of them as big brackets, I've got lots of things that can be factorised. So I'm going to write 2x minus 14 as 2 lots of x minus 7. This is a difference of 2 squares, so we can make it 2x minus 3, 2x plus 3. Times by, and we'll come back to that quadratic in a minute, or I should have given myself a bit more room there. Been a bit optimistic about how much room I need. And then on the bottom there, that one's also a difference of 2 squares, so x plus 7, x minus 7. Now your numerator, this is probably the trickiest bit to factorise. We know it's got to be 2x and x in the starts of the brackets, and I also know that the two numbers need to multiply to make 21. So it's either going to be 1 times 21 or 3 times 7. More likely it's going to be this one. So let's just have a think about it. If I put the 7 in this side, and the 3 here, I'm going to get 14x and 3x. Okay, yeah, I got lucky. First time. There you go, 14x and 3x, and that would make 17x. So we're happy with that. So I'm going to put a plus there and a plus there, and that's all good. Now let's simplify anything that we can. So in a fraction, if we can divide the top and the bottom by something, then we're going to do that. Because this is multiplying, you can think of all of this as one numerator and all of this as one denominator. When we times fractions, we just times everything on the top together and everything on the bottom together. So let's cancel. I can cancel x minus 7 there with x minus 7 there. And I can cancel x add 7 there with x add 7 there. And I can cancel 2x add 3 there with 2x add 3 there. So we're left with 4 over 3 divided by 2 over 2x minus 3. And we know that when we divide fractions, we keep, change, flip. So let's make it 8x minus 12 over 6. Everything there is in the 2 times table, so my final answer would be 4x minus 6, all divided by 3. And we've got it in the format that they asked me for, and that's it. 5 marks, lovely. Okay, question number 19. We've got 2x squared add 12x add 7, and we've got to write it in this format, so we are completing the square for this one. That's the topic. Okay, so the first thing I'm going to do, I don't like completing the square with the number in front of the x squared, so we're going to factorise that out first. So let's take the 2, put it outside big square brackets, x squared add 6x, and I'm not going to bother bringing the 7 into that, I'll just worry about that after. Now we can complete the square on this bit. So it's going to be x add 3, always halving that 6, squared. Take away whatever this is, squared, so that's take away 9, and that is what is now going in your brackets. So I've got 2 lots of that, and then I'm adding 7. Now expanding out that bracket, the square bracket then, I've got 2 lots of x add 3 squared, minus 18, because I've got 2 lots of this and 2 lots of this, and then add 7. So altogether, my final answer is 2 lots of x add 3 squared. I've got minus 18 and I'm adding 7, so minus 11. So A is the number in front of the bracket, that's 2. B is the number inside the bracket, that's 3. And C on the end, because they've got the minus here, we're not going to bother with our minus, so we'll just write 11 there. That's absolutely fine. If they had plus here, you would put minus 11 on the answer line. So there we go. If you wanted to know the turning point, not that we were asked it for this question, it's going to be whatever makes this bracket equal 0. So it'd be minus 3, and then whatever number you've got on the end here, minus 11. So that would be the turning point if you were asked for it, but in this case we weren't, so don't worry about that. Question number 20. Here is a cuboid with surface area S. Show that S equals 6x squared, add 24x, add 10. Now, on a show that question, you kind of want to come up with this entirely on your own. You don't want to be looking at it thinking, oh, okay, I wonder where they've got that from. They've given us information and things to do, so let's just do it. The surface area would be the area of all of these faces added together. Now I've got 2 faces the same for the front and the back. I've got 2 faces the same for the top and the bottom, and I've got 2 faces the same for this side and this side. So what I'm going to do is add together the 3 different faces and then just double it at the end because each of them has 2 of their faces. So this face on the end here, we're going to do x multiplied by x add 1. I'm then going to add on the area of this face here, which is x multiplied by x add 5, base times height. And then I'm going to add on the area of that face on the top, which is going to be x add 5 times x add 1. And then afterwards, we'll take it all and we'll double it. Okay, so let's expand each of those sections. I've got x squared add x squared add 5x, add x squared, add 1x, add 5x, so 6x, add 5. And we've got to times all of that by 2. So 2 lots of, let's collect it up, x squared, x squared, x squared, so 3x squared. I've got an x, I've got a 5x, and I've got a 6x, so that's add 12x all together, and then I've got plus 5. And if we double that, we get 6x squared add 24x, add 10, just as they asked us. So we'll give that a tick and say, yep, I'm happy we've got what you wanted. It then says, given that S is 58, find the length of the shortest side of the cuboid. So we now know that the surface area equals 58. So I'm going to take this expression that we had, 6x squared, add 24x, add 10, and we're going to say now we know that that equals 58. So we have a quadratic, and we know to solve it, we need to make it equal 0. So to do that, I'm going to take 58 away from both sides. 6x squared, add 24x, minus 48 equals 0. Now because this is now an equation and I've got an equals and I have values on each side, I can actually now divide this by 6 because everything's in the 6 times table and 0 divided by 6 isn't going to make a difference, and it's going to be easier for us to do stuff with and factorise and solve it hopefully. So x squared add 4x minus 8 equals 0. Now this is a clue that this is not going to factorise. So we can either complete the square or we can do the quadratic formula. Either is absolutely fine. So in this case, I think I'm going to complete the square just because it looks like quite a nice one. So I'm going to half the 4, x add 2, all squared, take away 4, take away 8 equals 0. So you're always going to take away this number squared and then bring down the other bit. So I've got x add 2, all squared, minus 12 equals 0. So x add 2 squared equals 12. We're then going to square root both sides, but remember that when you square root with a quadratic, you've got a positive and a negative solution. So x add 2 equals the square root plus or minus square root of 12. And we know that root 12 is, so x equals minus 2 plus or minus root 4 root 3. Because we're going to simplify this surd. So x equals minus 2 plus or minus 2 root 3. So because this is a physical shape and we're talking about a cuboid, we know that if we have minus 2 and we subtract more away from it, it's going to give a negative value, which we can't have for our physical shape. Our physical shape can't have a negative length. So we know in this case x equals minus 2 plus 2 root 3. And looking at the shape, they want the shortest side. If we add 1 and if we add 5, those are only going to be longer sides, aren't they? So the shortest side is just the one that is x, which is this, and we'll write it the other way around just for ease. 2 root 3 minus 2. You could have used the quadratic formula for that question. So you could have said a is, so from here, a is 1, b is 4, and c is minus 8, and you would have got exactly the same answer. So if you wanted to do the quadratic formula there, I've got a separate video on quadratic formula, so if you want some help with that, go and watch it. I hope you found that helpful. Please let me know in the comments if you've got any questions. I would love to help you guys, and happy revising.